Ancient mysticism relies on fluid, interpretive symbols. Modern software engineering demands rigid, deterministic logic. These two domains operate as exact opposites. The Valls-Clock protocol, branded as the Dalpazor Imperium, attempts to bridge this gap. It is a habit formation application that maps esoteric traditions into a functional software architecture. The system's conceptual layer is built from qualitative data. It incorporates the 72 microseasons of the Japanese 72-ko system, Kabbalistic angelic correspondences, and Goetic archetypes. Inside the application, this ornate lore is stripped away. The symbols are replaced by strict data hierarchies and minimalist UI panels. The central engineering challenge is one of translation, mapping abstract qualitative concepts into a programmatic environment where every variable must be defined. The solution relies on mapping calendar data into intersecting multidimensional arrays. Crossing these arrays generates the specific context needed for AI prompts and synchronized audio-visual entrainment. This allows the application to update without manual input from a developer. To understand the mechanism, we have to deconstruct the logic engine from first principles, starting at the database level. The daily ritual presented to the user is the calculated output of this relational database. The foundational layer is the macro loop. The system uses a 72-sequence calendar derived from the Japanese 72-ko, serving as the primary temporal dataset. In this database structure, each row acts as a primary key linked to specific attributes. For row 10, the variables include the sparrow's start-to-nest season, the angel Eladia, the theta bioprofile, and a 7 Hz frequency. These variables are routed into the front end, where they are formatted into a strict JSON schema. This schema populates the active UI view. For this period, the application displays sequence 10 and the headline, Sparrows Start to Nest. This architectural layer is completely static. The transitions are predictable and tied directly to the calendar date. The database also dictates which esoteric elements are loaded. During these 5 days, the element connections grid is populated with the specific spirit, brainwave state, and geometric form defined in row 10. While this macro loop sets the atmospheric theme, a 5-day duration is too broad to dictate granular daily actions. To drive daily behavior, the system introduces a faster temporal structure, the 5-day diamond protocol. This protocol cycles through 5 strict execution domains: somatic, community, economy, territory, and a final review. By nesting this 5-day loop inside the 72-period calendar, the system creates an intersecting coordinate matrix. Every day of the year is defined by an XY intersection, for instance, sequence 10, day 1. When the user reaches the end of this cycle on day 5, the interface updates to reflect the terminal coordinate, triggering the seasonal review. With these exact coordinates, the system has the specific context required to generate unique directives without manual authoring. When the user opens the app, the system detects the date and retrieves the active sequence and diamond day coordinates. This data is passed to the backend via a lovable cloud edge function. The AI combines the macro theme and the micro action directive to generate a specific daily task. The final text is injected into the dashboard. For sequence 10, day 1, the somatic directive becomes clear the debris from your physical workspace. Text generation is only half the pipeline. The database also routes non-textual parameters. The 7 Hz frequency parameter is passed to the Web Audio API, which generates binaural beats using an oscillator node. At the same time, the geometry parameter dictates the real-time visualizer rendered on an HTML canvas. The architecture translates a static database row into a synchronized, multi-sensory environment. The front end, built with React and Vite, manages these state changes across 360 unique days of data. A global theming system uses these variables to shift UI surface colors, accents, and glows throughout the entire application. The interface cycles through 5 primary color states: emerald green, gold, rose gold, violet, and cyan. For the system to actually drive daily discipline, the user must contribute data through sync logging and streak tracking. The application records this input and displays it as motivational metrics: the current streak, personal best, and total logs. This time-stamped journal entry is the final data point, anchoring the abstract concepts into the user's documented reality. The Valls clock protocol demonstrates that abstract frameworks can be systematized for productivity, provided the underlying software architecture is rigorously designed.